Today, we're going to talk about detail normal mapping. Let's get started. So in last week's tutorial, we talked about combining two normal maps together. And this week, we're going to talk about using that technique of combining normal maps to add detail to our rock asset here. This is an asset that I downloaded from Quixel Bridge, and I'll put the link in the description below for where you can grab this rock if you want to follow along. So this rock is a really nice asset. It's nice and high resolution, but the problem with it is if I zoom in, you can see that the texture starts to kind of fall apart because it doesn't have enough resolution. Now that is a problem because the texture maps that I'm using on this rock are actually 2048 by 2048, so they're really high res textures. But because the rock is unwrapped in a 0 to 1 UV space, I'm just not able to get the texture resolution that I need. So if my player character walks up too close to the rock, you can see that the texture detail just really falls apart. So today we're going to look at a technique of combining normal maps together and adding more detail to this rock. Let's take a look first of all at the assets that we have. So I've created a really simple material for this rock, and it just basically looks like this. It just has the albedo texture, and the albedo or the diffuse texture has the roughness packed into the alpha channel. So the red, green, and blue channels have the color of the rock, and the roughness is stored in the alpha. And the normal map is just a straight up normal map. Nothing really special about that. And then I created a material instance for the rock. And you can see that I have the albedo texture. And I've named the albedo CR_CR here. And that stands for color and roughness. And that way I know that I've processed this image in Photoshop so that it has the roughness in the alpha channel of the color. And the reason that I do that is so that I can get away with only sampling two textures, just to try to make my material as simple as I can. So if we switch over to Photoshop, you can see that here's my color texture and here's my roughness texture. And I've just copied the roughness. And if I switch to the alpha, I just pasted the roughness into the alpha channel of the albedo texture, and then I saved it with an _CR. So pretty simple. And once I did that, I imported it back into Unreal. And then I put those textures into the instance of my material. So here in the parameter groups, you can see that I have my normal map texture and my albedo texture. And then I assigned this material to my rock. So that's what we're looking at here. However, the problem, like I said, is when I get too close to the rock, the detail just really falls apart and it starts looking like a really low res texture. And pretty blurry, even though I do have a high resolution 2048 texture assigned. And so what I need to do is take a third texture and tile it a whole bunch of times and then overlay it on top of what I've got here. So let's take a look at this third texture. I'm going to switch over to Photoshop, and this is my detail normal map. So what I've got here is just a bunch of chunky, rocky looking details. And I have the red and the green channels packed with the X and Y components of the normal. Then I have some other data packed into the blue channel and the alpha channel. The blue channel for my texture contains a multiplier for the roughness, and the alpha channel of my texture contains an overlay for the color. And I'll show you how all of these work in a minute. But what I wanted you to see is that I've got the X and the Y components of the normal in the red and the green channels. And then the blue channel contains a multiplier for the roughness. And the alpha channel contains an overlay for the color. So pretty cool. I've got all of this detail packed into one single texture. And this will allow me to do one additional texture sample in the shader and get all of these additional details that I can add to my rock. Okay, let's go ahead and make the material modifications that we need to add this detail texture. So here we are in our material, and I'm going to come down here to the bottom where I've added a bunch of shader nodes. And here is our detail texture. I've gone ahead and imported it into Unreal. Let's take a look at that. So I'm just going to come down here and double click to open it. So here's our detail texture again. You can see that in the red and green channels, I have the X and Y components of the normal. In the blue channel, I have the multiplier for the roughness. And then in the alpha channel, I have an overlay for the color. Now there are a couple of settings that are important. Because I'm storing other detail in this texture other than just a normal, it's important that you not set the texture to be a normal texture. And so I've set the compression settings, instead of setting it to be a normal map, I've set it to be a BC7. And this is a good compression setting for a texture that's using 4 channels that have various just random data. It provides really good compression for a texture like this, where I've got a normal combined with other masks and other information. And then the other setting that's important besides BC7 is I've made sure to uncheck the sRGB because I'm not storing color data in this texture. I don't want to apply sRGB, so I have that turned off. Okay, so I went ahead and brought this texture into my material. And then for the UV coordinates, you can see I've got my texture coordinates here, and I'm multiplying them by 8. And what that means is in the same space that I'm applying my regular rock color and rock normals just one time across the surface of the rock, this detail texture is going to be tiled 8 times in that space. So if I do the math, my detail normal texture is a 2048, and if you multiply that by 8, it's like as if you had a texture that were 16,000 pixels by 16,000. So a pretty great texture resolution. So I've got my texture coordinates multiplied by 8. So here's my detail normal map, and I'm taking the red and the green channels, multiplying them by 2 and subtracting 1. Now I've talked about this before, but I think it's important to reiterate this. When you store a normal vector in a texture map, the range of the vector is between 0 and 1. But a normal vector's range is actually -1 to 1. And so if you're not storing your normal map as a normal, Unreal just thinks it's regular data. And so you have to go ahead and expand the vector yourself. And that's what I'm doing here. By multiplying by 2 and subtracting the 1, I'm adjusting the range of my normal so that it goes from the way that it's stored in the normal map, 0 to 1, to a vector, which is -1 to 1. All right, and then the next thing that I need to do is, because I'm only storing the X and Y components of the normal, I need to calculate the Z component of the normal from the X and Y. So I have this node here called derive normal Z. So I pass my X and Y coordinates of my X and Y components of my normal into the derive normal Z, and the result of that is a correct normal map output. So these two nodes here, times 2 minus 1 and derive normal Z, these 3 nodes together basically serve to unpack my normal map from my texture here. So that now that I have my normal map unpacked, the last thing that I need to do is use this blend angle correct normals and go ahead and combine my normal map with my base normal map. So here's the base normal map of the rock. Here's the detail normal map. And I use this node called blend angle correct normals that we talked about last week to go ahead and combine my base normal map with my detail normal map. Now I'll plug that into the normal input socket on my root node, and I'll save the shader, and we can go ahead and take a look at our results. So if I zoom in now, you can see that that detail normal map is adding some nice tight detail on the surface of my rock that definitely wasn't there before. So I can now zoom into my rock and see additional detail on the surface, and it kind of makes up for the fact that my base textures are kind of low res looking when I zoom in. So because I've added that extra detail, now I can zoom in significantly closer on my rock and still have nice tight looking details, and my rock still looks the same when I'm looking at it from far away. So that's detail normal mapping. Pretty cool. But you'll remember that I had some data stored in the blue channel and the alpha channel in my detail normal map as well. So let's take a look at how we can use those. I'll switch back to my material here, and you can see that I've got the blue channel here connected to a multiply. Now the blue channel, if we take a look again, the blue channel looks like this. It's basically white, but then I've got this these little crevices. And what this is intended to do is be a multiplier for my roughness. So if I switch back to my material here, my roughness is coming out of the alpha channel of my color texture. So I'm going to wire my roughness into this multiply and multiply it by the blue channel of my detail normal map. Then I'm going to wire that into my roughness socket. So not only am I modifying the normals of my rock, so I'm adding detail normals, but now I've also added detail roughness. Okay, and I'll save that and we'll switch over and take a look at it. Now this effect may not be as apparent as the normals because my rock is already pretty rough, so there's not a lot of specular or reflections going on my rock. But if I do have an object that's a little bit shinier, modifying the roughness like that and making it a little bit more rough down in the crevices will really help the specular reflectance of the object, and it'll add some more additional nice tight detail to the rock. Okay, well let's go ahead and add our detail to the color as well. So the alpha channel of my detail map has a color overlay, and the thing that's important about this data is that it's centered around 0.5. Like if we switch back over to Photoshop and we look at the alpha channel, if we do a levels adjustment, what you'll see is that my levels here are centered right here in the middle. So right about at the 0.5 mark, this data is centered, and that will allow me to do a color overlay so that areas of this map that are brighter will brighten it, and areas that are darker will darken it. So let's go ahead and do that. Switch back to our material here, and we'll take this node called a blend overlay and bring it up here to our base color. So I'm going to wire my RGB into the base, and then I'm going to wire the alpha channel of my detail normal map into the blend. And now I'll put that into the base color. And now, with one single detail normal map here, I've modified the color, the roughness, and the normals. And for all three of those, I've added additional detail so that I've got detail in all of the various material channels. So let's go ahead and take a look. All right, so now I'm modifying the normals, the roughness, and the color. And I can take a look at my rock from pretty good distance like this, and it looks great. Or I can zoom in nice and tight, and it still looks great. I've got tons of surface detail going on. Okay, let's switch over to Unity and take a look at how to build this same shader there. All right, so here we are in Unity, and you can see that just like I had in Unreal, I made this really simple rock material with the color texture and the normal, and I packed this smoothness map into the alpha channel of the color texture. In Unreal, it's roughness, but in Unity, it's smoothness. All right, and then I have my detail normal texture here, and I've taken my UV coordinates, and I'm just using the X and Y of the UVs, and I'm multiplying them to tile the detail normal texture across the surface with a higher frequency than the base color and normal map. Then I'm taking the X and the Y component of the detail normal map and combining them together and multiplying by 2 and subtracting 1. And again, the reason I'm doing this is to expand the range from 0 to 1 to -1 to 1. So I'm reconstructing the normal vector. Normally, if you sample a normal map, that's done internally for you. But because my texture is stored as a BC7 compressed, not as a normal map, Unity doesn't know that that's normal data. And so I have to go ahead and do this myself instead of letting Unity do it for me. And then I use the normal reconstruct Z node to construct the full normal X, Y, and Z from just the X and the Y components. So I've rebuilt my normal with these 4 nodes here. And then I'm going to take this normal blend node. Notice that the mode is set to reoriented. And what that means is that I'm using the RNM method that we talked about in last week's video, blending normals together. Then I'm going to plug my base normal map into the A socket and my detail normal map into the B socket. Then I'm going to plug my normal blend node right into the normal socket of my master stack. And you can see immediately that my detail normals show up. I've got a lot more detail when I'm zoomed in than I used to. Now I can also take my my blue channel of my detail normal map here and multiply that by my smoothness map. So I'll wire the result of that into smoothness. And then I can take my alpha channel of my detail normal map and overlay that on top of my color using the blend node set to overlay. Wire that into the base color socket of my master stack. So now I'm modifying the color, the smoothness, and also the normals. And so my result is this rock material that looks nice from a distance, and once again when I zoom in, it's got extra detail for looking at it up close. So that's how you do it in Unity. Alright, let's do a little review. If we take a look at our material again, you can see that we started out with just a base color texture with the roughness packed in the alpha channel and a base normal map for our asset. And then we added a detail map, which allows us to modify the color, the roughness, and the normals, and get a lot of really nice tight detail that we wouldn't otherwise be able to achieve. So we can zoom in really close on our asset and still get nice tight details. Okay, well this works pretty well for assets that are just made of one material. So the rock is just made of a rock, and so I can get away with just using one map. But what if I have an object like, I don't know, like a person, and the person has a leather belt and a cotton weave fabric shirt and maybe several other materials, and I've got all these materials packed together into the same texture. I can't just use one detail map because leather has different looking detail than the cotton weave of the shirt. So how am I going to handle that? What if I have an object, a prop, or a character that's got a bunch of different materials, and all of them need different types of tight detail maps? How can I do that without killing performance? Because I guess I could go ahead and clone this like however many times there are materials, but the more times that I sample unique detail maps, it's going to really hurt performance. So next week we're going to talk about how to do detail normal mapping when you've got multiple types of materials and you still want to have decent performance. So I hope you'll come back for that one. I hope you enjoyed today's simple detail normal mapping tutorial. If you did like this and you learned something, be sure to give it a thumbs up. I really appreciate that, you guys. And I hope you have a great week and come back next week where we'll talk about detail normal mapping with multiple material types. Thanks for watching, and we'll see you next week.